Welcome to a journey through the minds of giants, Isaac Newton and Gottfried Wilhelm Leibniz. Both independently invented calculus, but their method sparked controversy that will shape mathematics forever. Isaac Newton, year 1642 to year 1727, was an English mathematician, physicist, and astronomer, best known for his law of motion, universal gravitation, and groundbreaking contribution to the optics and mathematics. He began developing calculus in the mid-1660s, though he did not publish his work immediately. On the other hand, Gottfried Wilhelm Leibniz, year 1646 to 1716, was a German polymath, philosopher, logician, and a mathematician who independently developed calculus during 1670s and 1680s and published his work in 1684. Beyond mathematics, Leibniz made a significant contribution to the philosophy, metaphysics, and logic, making him one of the most versatile thinkers of his era. Newton developed calculus to describe physics in motion, like planetary orbits, instantaneous rates of change, and other physical phenomena. Meanwhile, Leibniz aimed for a universal system that applicable across the field. Both were driven by Europe's needs for advanced math and science and engineering. Newton described calculus using his concept called fluxions, or derivatives, or fluent, or integrals, interpreting quantities as rate of change over time. While his method were mathematically sound, his notation was less intuitive and did not spread widely outside the England. In contrast, Leibniz introduced the elegant and enduring notation of dy and dx for the derivatives in the elongated of integral. His symbols were clear, systematic, and universal adaptable, which made them far more practical for teaching and applying calculus. Though both approaches were mathematically equivalent, but it was Leibniz's notation that endured and remained the standards of modern calculus.
The contributions of Newton and Leibniz laid the foundation for calculus, which has become a cornerstone to modern mathematics and science. Calculus opened the door to analyzing motion, growth, change, and optimization with precision, transforming the way natural phenomena were understood. Its applications span across physics, engineering, economics, biology, and computer science, underpinning much of the progress in these fields. Without their breakthroughs, monumental advancements such as Newtonian mechanics, Einstein's relativity, and the analytical methods used in modern data science would not have been possible. Despite their shared achievements, Newton and Leibniz became embroiled in a heated dispute over the priority of discovery. Newton had formulated calculus earlier in the 1660s, but kept his work largely unpublished, whereas Leibniz formally published his result in 1684 and gained recognition for the discovery. By the early 18th century, accusation of plagiarism emerged, the Newton supporters claiming Leibniz had borrowed ideas from Newton's unpublished manuscripts. The conflict escalated into nationalistic rivalry between England and continental Europe, ultimately tarnished Leibniz's reputation. Modern historians, however, agree that both men developed calculus independently, each contributing uniquely to its development and legacy.